As petrol and diesel vehicles become more complex and more efficient, so too does the media used in their filters. This allows them to meet the increasing demands of longer service intervals. Welcome to the Ryco Filters Training Academy. Media can be made via a chemical or mechanical bonding, in which a variety of fibre types are used. These may be natural or biofibres, which include cellulose, synthetic polymers like polyester, and inorganic fibres from glass. The fibre type chosen will dictate the media properties, such as porosity and adsorption. Specific properties such as fire retardancy can be attained using specialised chemicals, such as polyacrylic acid during the bonding process. In effect, media is an advanced composite, not unlike other exotic materials found in the modern vehicle. The structure is a maze of fibres and channels, rather than precisely sized straight-through pores found in standard wire mesh. Filter paper provides the means to remove the greatest possible amount of contaminant, while offering the least possible restriction to flow. The porosity of filter media is measured using a micron rating, which is in fact the pore size. The value will be expressed as either nominal or absolute. A nominal rating means the size is measured as the percentage of particles at a given size that the media can capture. In real terms, we could say that a media with a 10 micron rating at 90% nominal will capture 90% of all particles 10 microns or greater in size. An absolute micron rating refers to the removal of all particles at a given or larger size. We could say that a media with a rating of 20 microns absolute means that 100% of all particles 20 microns or larger will be captured. The lower the micron rating of the media, the greater its efficiency, and so more particles are captured. Basis weight is the value given when measuring 1 square metre of filter paper. The SI unit is GSM, or grams per square metre. Filter design is a balance between efficiency, life and flow. Media pleating has a direct bearing on the flow rate, as the number of pleats will determine the amount of media used. Too few pleats equals little media and a low capacity, although too many pleats will result in flow problems as the media bunches together. This is known as core binding. There are several different processes at work within operational media. Direct entrapment or interception is when particles are trapped on the surface or within the fibres of the media. Adsorption involves the adhering of contaminant molecules to the surface of a solid adsorber, which works by attracting the contaminants that are smaller than the pores in the media. Direct impingement occurs when the contaminant particles attach themselves directly to the surface of the media fibre, rather than being trapped within a pore. The particles are held by either absorptive forces or the flow of liquid or gas passing through the media. A Brownian movement is seen when extremely small particles have their trajectory governed by Brownian spin phenomenon. The particles move through the filter media without regard for the direction of the liquid or gas flow, and eventually become attached to the media surface by adsorptive forces. A filter cake occurs when particles of contaminant build up on the surface of the media. Over time, the contaminant begins to function as a filter, trapping smaller particles in the pores or gaps between the fibres. As more and more particles build up on the filter cake, restrictions to liquid or gas flow increase. Ryco measures its filter's performance against the 3 key standards of efficiency, life and flow. This measurement, known as ELF, is about achieving a critical balance between the overall efficiency of the filter's operation, its ability to hold contaminants throughout its service life, and the highest possible flow specifications to ensure better engine performance, reduced wear and lower emissions. ELF is the cornerstone of Ryco's design philosophy, ensuring that all of our automotive filters meet or exceed OE standards. Let's have a look at how Ryco selects different media for its filter products. Media selection is always paramount when developing a new filter, and Ryco takes a rigorous approach to achieve the ideal balance between efficiency, life and flow. This is a part of Ryco's overall mission to deliver products that meet or exceed OE standards every time. Ryco benchmarks original equipment, efficiency, life and flow, and advises suppliers on the media grade required. Media is selected based on several factors, including media type, area, weight, burst strength and pore size. In many instances, the media may appear different to the original equipment filter. However, meeting or exceeding the performance of an OEM is paramount to Ryco's design philosophy. Regular air filters require a highly specialised dry type media, manufactured with a synthetic or multiple layered construction that has a very high dust capacity to suit Australian operating conditions. It's not just engines that need clean air, but all occupants within the vehicle also need to breathe. Cabin air filters significantly reduce the amount of dust, pollen and external odours and make for a comfortable environment within the passenger cabin. Reduced fuel consumption and tighter emission controls has led to technical advances in fuel injection systems. Extremely high injection pressures require extreme filter performance. Removing impurities, moisture and contaminants from the fuel requires an exceptional media construction. Longer service intervals and higher efficiency requirements are the instigators of sludge creation within the lubrication system and are placing greater demands on the oil filter than ever before. Cellulose, synthetic or glass fibres are used individually or in a combination to create the perfect Ryco oil filter media for each vehicle. Again, be sure to follow the Ryco Filters Training Academy and develop your knowledge with the market leaders in filtration. Thanks for watching.